Professor, you're muted.
Here you go. Now you can hear me. I was momentarily without internet. Thank God I have two internet services here as a backup in case one is not reliable, right? So I switched to the other internet provider and now I am back. Thank you for your patience there. I pay two internet bills to make sure I am in contact with you all the time. Now let's share the screen. And here you go. So here you go. First step, right? First step is to measure the resistance of the resistor that we are going to put in the circuit to verify Ohm's law. And that's what this table is all about, okay? Resistor number one, that's the value of the resistor number one for this group, right? That's the first step. And I will get my notes as well. Okay, here. And so we start with the list of materials. The list of material, the first material is the resistor. Okay, we reuse the resistor in lab 3 and 4, labs 3 and 4. And the other equipment, list of materials equipment, right, is the digital multimeter. We have used the materials / equipment. We use the digital multimeter in all the 4 labs, 1, 2, 3, 4. Lab 1, we use as a volt. Labs 1 and 2, we use it to measure as a voltmeter. Lab 2, we use as a voltmeter as well, right? Just like I mentioned before. Lab 3, we use the DMM as an ohm meter. In lab 4, we are going to use the DMM both as a voltmeter and ammeter. Ammeter. Here you go. Digital multimeter. Oh, we're going to use an ohmmeter as well, right? Because we measure it ohmmeter. Ohmmeter, yeah. We saw that, yeah. So the first 3 labs, we use the DMM just as one device. In this 4th lab, it's going to be a little bit more complicated. We are going to use the DMM as 3 different devices, the ohmmeter, the voltmeter, and the ammeter. And you can switch, right? The dial function that we have in ammeters allows you to do exactly that, okay? Right in here, you can switch for different measurements that you do. Okay, next. Oh, I already showed the spreadsheet, right? We start with the power supply. We're gonna put which is the battery, right? Which is the battery. And the power supply, we use power supplies in all the 4th lab, all the 3 previous lab, and we're using in this one as well. So power supply lab 1, 2, 3, and 4. This is my battery. The power supply is the battery here in the simulation of the circuit. The battery provides the power. Let's start all again from scratch, right? And then we follow the circuit that we're putting together here in the simulation as well. Here you go. Power supply, battery, right? 2 black cables and 2 red cables is banana plugs. 2 black cables and 2 red cables is banana plugs, okay? We use black cables and red cables in lab 1, 2, 3. And they are banana plugs. Let's see here. I'm gonna get right. The black cables and the would be this one here. I'm gonna turn off the, oh, not this one. I'm gonna turn off the electrons. Here they didn't illustrate the cables as black or red, right? They illustrate the cable just as a copper color. But that's what those cables are all about. They should be our black and red cables with a banana plug. And pick up 2 black cables and 2 red cables with banana plugs. And 2 alligator clips. We use alligator clips all over our labs. It's a very convenient way of clipping the resistor. Okay. Now let's take a look here. Red cable coming out of the power supply, connecting to the resistor with my alligator clip, and closing the circuit with the black cable. And I'm going to do the same here in the simulation. Here you go. I got to close the circuit right in here. I'm going to even do like that, you know, to cut down on the cables, on the wires. Here you go, the resistor. Make it look nice. Move a little bit to the center. Okay. So here you go. Here's our circuit. This circuit that you see here is exactly the same that you see in my PowerPoint. Power supply, cables, and resistor. Exactly the same. And that's the circuit diagram showing a switch that I didn't illustrate here. Okay, let's close the switch. Here you go. Now the current should be flowing through this circuitry.
Professor, I don't think we're recording.
Oh, I'm not recording? I know, I think I am. Let me check.
Oh, okay. I don't remember.
It automatically record when I come online. Let's see here. Pause, recording, resume recording. Yeah, here you go. And when I close the switch, the electrons flow along the circuit. Okay, the direction of motion of the electrons is in the counterclockwise direction because they are negative charges. However, the direction of the current should be in the clockwise direction because the direction of the current represents the direction of motion of the positive electric charges. And if I do the conventional way, right, I can do the conventional way. It switches for the direction of the current, not the direction of motion of the electrons, but the direction of the current that corresponds to that direction of the positive charges, if the positive charges were the current carrying, okay, or if they were, but in reality they are not. In this lab, like I said, what are we going to do? We are going to start with 10 volts, and little by little, we are going to decrease the voltage, right? Go back there in your spreadsheet. We start at 10 volts, go to 8 volts. Oh, 10 volts, and then what do we do? 10 volts, you measure the voltage. The voltage across the resistor. Okay? but I gotta put 10 volts here first. It's 9.5 right now. Yeah. Okay. For this specific resistor, the voltage is going to be 10 volts. Actually, it's not going to change because it's a single resistor in a single circuit, right? If I change the voltage of the power supply, the voltage across the resistor is going to be the same. Okay, and that's exactly what I get in my spreadsheet. My spreadsheet right in here. 10 volts here for the power supply, 10.03 volts for the voltage across the resistor. That's what V1 is. Going back to my, here you go, multimeter, right? My slide. Here you go. Red cable of the other two red cables. Here you go, black cable. Whatever voltage is indicating here in the power supply should indicate here in the ammeter. Not exactly, but close enough. Here is the circuit diagram. Voltmeter. Okay. And we are measuring only the voltage for now. We're measuring the voltage. Is always easier to measure than the current. So decrease the voltage provided to 8 volts, and you measure the voltage with the multimeter. Go back to our simulation, right? 8 volts. 8 volts. The ammeter, the voltmeter is measuring 8 volts. Next, 6 volts. The voltage read by the digital multimeter should be close to 6 as well. Check. I want you to double check there in your spreadsheet, okay? 10, 10, 8, 8. Oh, 8, 8.08, right? 1% difference. 6, 6001, right? 4, 4064, slightly more than 1% difference. And then 2.8, 2.781. We got 1, 2, 3, 4, 5 data points for the positive voltages. Next, what do we do next? We invert the polarity of the device. In order to do that in our simulation, we switch, right, the polarity of the battery. Did you notice that the current changed the direction of flow? That's one direction. Voltage is positive. Change the direction. Voltage is negative. Okay. And we repeat for, 2.8, right? Start with 2.8, and then we increase back to 10, minus 2.8. Double check that, double check those numbers. We are working only on those two columns. 2.8, 2.781, minus 4, minus 4022, minus 6, minus 6078, minus 8, minus 8065, minus 10, minus 10.041. That's what we gotta do here. And next, you're gonna see here that let's see, yeah, this slide here shows that we inverted the polarity of the power supply, right? Initially, the red was connected to the red of the power supply. After switching the polarity of the power supply, I connect the red cable to the black plug of the power supply, and we get negative voltage. Okay. procedure, right? Let me write that down, the procedure for you. List of materials, here you go, procedure. Measure the resistance of the resistor with the multimeter. Plug the red banana cable into the red output of the power supply. Connect the other end of the red cable to the resistor using alligator clip. Black cable with banana termination. Connect to the black plug of the power supply. Connect the other end of the black cable to the other end of the resistor using alligator clip. Connect the DMM in parallel to the resistor to measure the voltage. Take your voltage measurements with the multimeter. There you go. Start with 10 volts, right? I'm just documenting what we did. Start with 10 volts in the power supply, measure the voltage in the resistors, DMM, then change the potential to 864 and 2.8 volts. Take the voltage measurement with the multimeter, change the polarity of the circuit by plugging the red cable in the black plug of the power supply and the black cable in the red plug. Repeat measurements in item 7A and 7B. Never connect your voltmeter in series your circuit, okay? You're not burned out, but you get a zero measurement. Yeah, very important. And now, no, we measure, we took voltage measurements. We're done with the voltage measurements. And now we are going to go for the measurements of the current. We can go to the C here, measurement of the current. We are going to make two independent current measurements. That's what we do in the lab. We do two independent current measurements. So you can see that no matter where you go in that circuit, you get exactly the same measurement at two different spots. At one spot, close to the positive terminal of the battery of the power supply, you get 5.143 milliamps. In the other spot, you get 5.11 milliamps, right? Only a difference in 3 in 500. 3 in 500 is less than 1%. Is a 0.5%. Okay? So look what happens. As I decrease, and let me show you where this measurement is, okay? So here you go. And then here you go. I'm taking the circuit apart. I start with the power supply and the red cable, and I connect the power supply to the ammeter. Okay? The yellow plug is for measurements in current. The red plug is for measurements in volts and resistance. If we do that in the simulation, how do we do that in the simulation? We have to take the circuit apart and use the ammeter here. Let me show you how we do that. Here you go. I'm gonna reset, right? Introduction, start all over again. Here you go. Power supply, right? That's the power supply there in my PowerPoint. Wire connected. That's a shame. This ammeter is not. This ammeter is not, how do you say, realistic. Unfortunately, they didn't do a realistic ammeter here. Okay, but in real life, you connect the ammeter to one polarity of the ammeter, right? You connect the wire to one polarity of the ammeter, just like we do with the voltmeter, okay? In real life, it would be something like that, okay? That would be the ammeter. You connect one lead of the ammeter to the wire, and then the other lead to the other wire, and the resistor. That's how you do it in real life. Unfortunately, they didn't make it realistic in this simulation. Unfortunately, but it has to be an ammeter, not a voltmeter. Okay? So let me take this one out. Let me show you how we do in tab. Okay, take it out, put it back, right? So the way we do in this simulation is like that, which is not realistic, by the way. We have this guy here, right? We put it right in here, and he measures the current flowing. Okay, it's like a loop, right? A loop. It's a viewing device. That's not how it's exactly done in real life. Unfortunately, they couldn't, they couldn't do a more realistic simulation specifically for the ammeter. And okay, so let's continue here setting up the circuit. The ammeter is in series. Okay. Oh, one very important difference between the ammeter and I want you to remember that, okay? Very important difference between the ammeter and the voltmeter. I'm going to put it here. Very important difference between the voltmeter and the ammeter. The voltmeter is connected in parallel to the elements of the circuit. Okay, so here you go. One, the voltmeter is connected in parallel to the elements of the circuit. The ammeter is connected in series with the elements of the circuit. See the difference? Series and parallel. Very important differences, right? Very important differences between voltmeter and ammeter. I'm going to even make a table for you. Insert table. 2, 3. Let's see. Let's try that. Voltmeter, ammeter. Okay, first we start with the measurement, right? The voltmeter, of course, the voltmeter measures. Let's see, are you ready for the break? Let's see here. Oh, time for the break, right? Let's go straight. Volts, current. Okay, connection. Parallel, connection with the circuit. Circuit. Parallel, in parallel, in parallel, in series. Okay. And what else? There is one more thing here. By the way, very important, another internal resistance. Very large, very small. Okay? That's the important difference between the voltmeter and the ammeter. I don't need that. Can you remember that? Okay, never connect your voltmeter in series with your circuit. Okay, let's go measure the current now. Voltmeter is connected in parallel to the element of the circuit, right? Oh, wait a minute. Okay. Let's see. Okay, so there's a typo here in my notes. The ammeter is connected in series with the elements of the circuit. Okay. So red cable to red plug of the power supply. You saw that, right? Red cable to the red plug of the power supply. Other end of the red cable to the yellow plug to the yellow plug of the DMM. Okay. One end at the red plug of the power supply. The other end at the yellow plug of the multimeter of the DMM. Black cable into the power plug of the DMM. That's what I told you about the simulation. Is not very realistic what they did there. Other end connect to the resistor. You go. We're going to close the circuit now. Black cable to the black plug of the power supply to the other end of the resistor. Right? And here you go. We close the circuit. That's how it looks like in a diagram, circuit diagram. Okay, and that's how it looked like for the voltmeter. Voltmeter in parallel, ammeter in series, right? We are measuring the current. Never connect the ammeter in parallel with the circuit. You can damage your DMM. Okay. And then you invert the voltage, okay, the polarity. So here what we did, we put the ammeter at this spot right in here. That's what the I plus is all about. That's the I plus is all about. Close to the positive of the power supply. As the voltage decreases, the current also decreases. That goes according to Ohm's law. As the magnitude of the voltage increases, the magnitude of the voltage of the current also increases. What we have here is just the same measurement, but a different spot. I put the ammeter, I always tell my students put the ammeter on the other side here so they can verify that the current is the same for this specific circuit. Check that, right? Compare this measurement with this one here. Compare this measurement with this one here. They're very close to each other. They're not exactly the same, but they're very close to each other. Less than 1% difference. This one and this one, right? This one and this one, and so on. Okay? So those are all measurements Let me highlight with yellow, right? Measurements. And the remaining here, they are all calculations. Let me put with a different color. Brown, yeah, here you go. Results, calculations, right? What do you have to do? What do you have to do? We are going to verify Ohm's law. You have to plot, remember Ohm's law, right? Let me just copy here and paste in the notes. So you have everything that you need. Never connect your ammeter in parallel with your circuit. In parallel. Remember that Ohm's law V equal to Ri. We measured V, we measure I, we measure R as well, right? When you plot V along the y-axis and I along the x-axis, we should get a straight line with a slope equal to the resistance. That's how we verify Ohm's law. Okay, and that's what you're supposed to do. Plot V1 along the y-axis and I average along the x-axis. Let's do that together. I want everybody to do that, okay? I want everybody to do, here you go. I average V1. Insert chart scatter plot. Do we get a straight line? We do, right? If you don't get a straight line, that's because you're doing something wrong. I consistently get students who try to do this plot in the cloud, in the Google Drive, and it doesn't work. It doesn't work because Google Drive doesn't work, okay? Doesn't work for plots. You have to download this spreadsheet to your hard drive and run from your hard drive. And go ahead, change the chart, make it look nice. Here you go. Add trend line, display equation on chart, display R square on chart. My equation is very small, right? But you should be able to read yours. If you're getting one here, make sure you change the number of decimal places. Format and line label, okay? Put it in number format. And increase the number of decimal places until you see a number that's not 0 or it's not 1. Like that. R square is very close to 1, but don't log it R square 1. I want you to find out a known unit value for R square. Any questions? The graph is the most important part of any lab. Okay, let's see how you are doing. Roster. Want to know if you plot your graphs. Plot the graph. Okay, Oni, did you plot your graph? Is Oni there?
No, not yet. I was doing the other lab, but I'm going to do. I'm gonna plot it afterwards.
Okay.
Okay.
Now, working on that. Here you go. Mirage is not here. Okay, Susan, did you plot your graph?
Yes, I plotted already.
Okay, any problems? Did you have any problems?
No problems.
Okay, good. So we spice it up, make it look nice. Evelyn is still not here, right? Christina is still not here. Emily Serna, looks like she left. Next, Isabella Cisnero. I don't see Isabella here. Next, no, Emily, Isabella, no, Gabriela. I don't see Gabriela. Arwa, I don't see Arwa. Princess, did you plot your graph?
Yeah, I did plot, but for the R square, is it normal to just get one number?
Yeah, no, you shouldn't, you have to adjust the number of decimal places, right? Just like I did now. Let me show you. Okay, you have
Okay.
you have to adjust the number of decimal places. Let me plot it again. Let's see
Okay.
here. I'm gonna repeat what I did. Here you go. Click, right click, add trend line, right? Display equation chart, display R square value. You see that I got one here?
Yeah.
Okay, so how do we fix that? You click the box,
Mm-hmm.
right click the box,
Mm-hmm.
format trend line label,
Okay.
okay?
Mm-hmm.
Change the category to number, and add as many decimal places as required to see a number that's not one. Okay?
Okay.
2, here you go. It's still 1, right? If I
Mm-hmm.
put 3 decimal places, this slope is changed from 0 to 0.001, right?
Mm-hmm.
And then but not the intercept, but the R square is to 1. You gotta keep on adding, until you see a number that's different of 1 and the other numbers are different of 0. If I put 6 decimal places here, my R square changes value, right?
Mm.
Okay, that's
Okay.
how you should do it. You gotta play it with it until you get the number, a number that's not 1 for R square,
Mm-hmm.
and a number that's not 0 for the slope and intercept.
Okay.
Okay.
Thank you.
That was Princess, right? Yeah, that is. So let's say you're working on that. Kimberly Morales, not here. Trin Hernandez, not here. Stefan,
Yes, I just finished it. I also, for when the class ends, could I ask you a question about lab 3?
sure.
Thank you.
Remember, I postponed the deadline of lab 3, right?
Yes.
You're all aware of that, right? Okay, Stefan. So you finished, right? So you got the graph. That's what I mean by you finished. You got the graph. Jeremy.
Yes.
Jeremy. I see Jeremy is here. Are you there, Jeremy? Jeremy must be away from his computer. And let's put Paola.
Professor, I texted in the chat. I'm working
you
on it right
tested.
now.
Okay. Sometimes I miss this text here is hidden in my computer. I'm working on it. Okay, almost done. Are you talking about the graph, right?
Yes.
Okay, good. Paola. Oh, you plotted. That's good. So move on to the units, right, Paola? Move on to the units. Let me show you. I keep on seeing that over and over again. Many students, they fail to write down all the units. It's so easy to do that, Units here, unit here, unit here, here, here. I'm gonna put it in red color, right? And here you go. What else? We have units. We have units here and here. So you have 1, 2, 3, 4, 5, 6, 7 cells to write down the units. Write down the units, okay? Make sure you start working on the units. Let's see, I'm gonna even put that color code here. Units. Color code for you. Next. Pedro Lopez. I don't see Pedro here. Next, Isabel Medina. I don't see Isabel. Next, Ariane Navidias. I don't see Ariane. Catherine Perez. Nadia Pram. Jason Cervellon. Hello, Jason. Are you there, Jason?
Yes, sir,
Okay.
my microphone wouldn't turn on.
Okay. Did you plot your graph?
Yes, I plotted it.
Okay, good. So you should start working on the units, right?
Yes,
Okay, thank you. Dana,
thank you.
Dana Terry,
Yes,
you plot
I
your graph?
plotted it. I'm cleaning it up now. Yes.
You're finishing now? Okay.
Yes.
So we start with the units now.
Okay.
Okay, next is Ramon. Ramon here. No. Okay, we're not gonna have our second break, okay? We're running out of time here. Audrey, Tylery.
Yes, I plotted. I just have a
Okay,
question.
yeah.
When we do like the V1 and the I, and it shows it in scientific notation, how many decimal points should that be when we change it to like a number format?
Okay. Oh yeah, we are gonna get there. We're gonna get there.
Okay.
It is the significant figures. Okay.
Yeah.
So
Okay.
let me give you the answer right now. You use that table, right? The P07.
Yeah.
You use that table, and let's go there. I've got a. You have to use that table where it says current. It depends, right? He goes sig figs, right? P07 sig figs. Okay. So here you go. Download it. Okay. So here you go. The table, not the resistance. Let's see. Yeah, remember, in this lab, you're going to use the table for the resistance, for the significant figures, right? Because we measured, this lab is a little bit more complicated, okay? Here you go. It's a little bit more complicated. See, things are getting a little, here you go. For this value that you see right in here in the resistance, you are going to use this table, this first table, resistance of DMM. Okay. Now, do you see V sub here? Power supply. We also have significant figures. So for the, can you write that down so you don't forget? Here you go. For this column here, for the V sub power supply, you use that second table that you saw. Okay. Here you go. It shows here the number of significant figures. Okay. Are you following? For V1, you use this table, voltage DMM. Okay? For the V1, you use this table here. And for the current, you should have the number of significant figures for the current. You use this table. Okay? So this lab is using all those four tables. All those four tables. For lab number one, note C, for lab number one, we used only this table for lab number one. For lab number two, we used only this table. For lab number three, which was resistance measurements, we used only this table. See the difference now? And now for lab number four, we are using all those four tables. You will have to refer to all those four tables for the significant figures.
Thank you.
Okay, is that clear? Or too complicated?
Yes,
Okay.
it's clear. Thank you.
Okay. So I'm gonna write down in the notes so you can have something written for reference, right? So we plotted, and now I can, let's see, I can, okay, Carlo Gallardo.
I'm here.
Did you plot the graph, Carlo?
Yes.
Okay, good. So you can do the units, right? Are you doing the units already?
Yeah, I'm doing them right now.
Okay, good. So next is Steve Sanchez. Hello, Steve. Oh, Steve Sanchez applied here. Good. Yes, I did, Professor. I'm doing the units too. Okay, good. And next, Ben Bandoy. Hello, Ben. Let's see. Okay, did you plot the graph, Ben? Okay, good. Did you work in the units? Oh, already did the units. That's good. Insert units. So you finished the units as well. What about the sig figs? What about the sig figs, Ben? Fig. Already got my CL and I'm working on sig figs. Okay, good. You know how to get the sig figs, right? Okay, good. Next is Noemi Martinez. I don't see Noemi Martinez here. Luis Cruz. Luis Cruz left. Huh? Okay, Luis Cruz left. Jenny Maldonado, I don't see Jenny. Mikara Alkema, I don't see. Ryan Alkema. Chris is not here either. Next is Delacia. Delacia is not here. And Juan Torres Arellano. Juan Torres Arellano. Are you okay? Juan is here, right? Hopefully he's in front of his computer. Okay, good. Okay, did you plot the graph, Juan? Oh, you're working on the graph. Okay, good. So let's see, 10 more minutes to go, right? 10 more minutes to go. Let me, don't forget, plot the graph, right? Plot the graph. To-do list. To-do list. 1, plot the graph. 2, fill up the units. 3, work on the significant figures, sig figs. And then I'm going to elaborate here. Work on the sig figs. Using, work on the sig figs using the PDF file P07 sig figs. Sig fig. Not sig figs, sig fig.pdf. Okay. 1. For the sig fig of the resistor in the first table, okay? And then let me write that down. Cell, what's the cell number? Cell J4. I'm even going to, J4. Use the first table of the document, right? B. for the sig figs of the power supply V sub. Font, where's font here? Right here, V sub, okay? Cells, here you go, F11 through F20, cells F11 through F20 in the spreadsheet. Comma, use the second table in the document. Right? First table, second table, power supply. Here you go. For the significant figures of the DMM measurement of the voltage V1, okay, 1, 2. What are the cells? I'm gonna tell you what the cells are. G11 through G20 cells. G11 through G20 use the third table in the document. Orderly, right? That's orderly. What else? Here you go. For these cells here, these two cells here, okay? For the significant figures of the DM measurement of the current, we are running out of time, huh? AI plus and I minus which are cells H11 through I20, right? In the spreadsheet, use the force table in the document. Okay? And now, here you go. What about for those cells here? You also have to worry about the significant figures. For, let's see, 447, okay, we're getting there. J, okay. For the significant figures, for the sig figs of I average, in cells I11 through, no, it's not I, J, right? J11 through J20 in the spreadsheet, comma, use what? Use the rule for addition, right? Now it's not a measurement. This is not a measurement. This is a result. So you have to use the addition rule. use the addition rule. Okay? For the significance figures of the power and R1, right? And for significance figures of P and R1 in cells JK, right? K11 through K20 and L11 through L20 respectively, comma, in the spreadsheet, use the rule of multiplication, the multiplication rule. Use the multiplication rule. Multiplication rule. Use the addition rule. Okay? Now you have everything that you need to display the measurements and the results with the proper number of sig figs. Okay, and here, right, you already should know what to do. Don't forget to log in the values in this last table. Those are the units. Any questions? We're running out of time here. That's 12:50. Okay, we run out of time and they'll be here for the office hours. I see you on Monday.
Thank
Thank you for attending. Bye-bye.
Hi, Professor. I have one quick question.
Yeah.
About the homework that you graded, it says that it's 0, but I completed the homework on Wiley, but it's not showing up on my Canvas.
Okay, which homework are you referring to?
The 1 and 2.
1 and 2?
Yes.
Okay, let me stop sharing the screen and I'm gonna check addition and multiplication. Okay, okay, Susan Acosta is asking us the rule of addition and multiplication. Let's see, let me help, hang in there, Susan, let me help Dana, and I'll answer your question, okay? Let's see, let me stop sharing the screen. I'm also gonna stop recording and remind me if I forget to help you, okay, Susan? Let's see, pause.